We're solving problem 18 from the Spring 2021 AMC 12B. Let z be a complex number satisfying 12 absolute value z squared equals 2 absolute value z plus 2 squared plus the absolute value of z squared plus 1 squared plus 31. What is the value of z plus 6 over z? So it's important to notice that in this case, for any imaginary number, we can set an imaginary number, in this case z, equal to a plus bi. It is then shown, or it is then then we make this distinguishment that we know that z squared is a squared minus b squared plus 2abi. This is where all of this comes from. When you first plug in these values, z equals a plus bi, you get this initial equation right here, which doesn't seem too bad, at least right now. But then when you multiply it out, it's just like algebra at this point, where there's no imaginary part since this part, and there isn't even an imaginary part here since this absolute value. So you just multiply it out and then order it like a polynomial, where the highest powers are at the front and the lower powers are at the back, and some things can cancel out. This is where the real insights into this problem begin. We can basically just start by completing the square. We see that this a4 plus b to the 4 can be paired with this 2a squared b squared to make a perfect square, which is a squared plus b squared squared. So a squared plus b squared squared. And then, we want to have ideally another factor of this, and we have a minus 12b squared and minus 8a squared. This part is really tricky, but you want to find minus 12a squared plus b squared. Why? That's because since this is a minus 12a squared and you initially started with a minus 8a squared, you want to add back a 4a squared. So you add it back, 4a squared. And then since you factor out the 4, you can factor out the a's in the remaining terms. So we're left with this. And then you add a 2a, and then you add a 1 from this. So you add a 1. And then you add a 1 at the end of this, but this is actually 4 since from 36. And now we see that this can become a perfect square, and then all these other terms, a squared plus b squared squared minus 12 a squared plus b squared plus 36, those three terms can be a square. So we get that this is a squared plus b squared minus 6, since the square root of 36 is 6, and then you add 4a plus 1 squared is 0. From this, you get two equations. A squared plus b squared minus 6 equals 0, and a plus 1 equals 0. It is then from this equation that a is equal to negative 1. And then it's pretty easy on out to solve for b. Well, we then get that b is equal to, since a squared, a is negative 1, a squared would be 1. And then 1 minus 6 is 5. And then we get that b squared is 5. So b is equal to the square root of 5. So our answer, we want to find z plus 6 over z. Z plus 6 over z is then, since you want to have a common denominator of both z's, this becomes z squared over z. Z squared, as shown above here, is denoted by a squared minus b squared, and then you want to add over the 6 plus 2abi over a plus bi. And then it's fairly simple to plug in the terms and then the terms of I will cancel out. So when you plug in a is negative 1 and b is equal to the square root of 5, you get that this is equal to negative 2, our answer for this problem.